Hello everyone, this is our study of chromatographic analysis of polycyclic aromatic hydrocarbons in soil. My name is Wu Shenhan. My partner is Chen Deheng and Soming Wei. This is the introduction. The soil around chemical plants is often contaminated due to long-term emissions, leakage, and waste disposal. This soil contains light hydrocarbons, aromatic compounds, and high-volume pHs with very different volatilities. There are similar structures and strong adsorptions, especially for high pHs, make separation difficult and pose long-term environmental health risks, require a reliable analytic method. This is the design and challenge. Temperature program how initial temperature retains light components, moderate ramp improves separation of aromatics, and high temperature ensures complete elution of heavy pHs. Analytic challenges peak overlap, incomplete elution of high volume pHs with matrix interference may lead to underestimation of contaminations. This is the reason why I use GCMS. First one is the handles wide boiling point range. The second one is the high selectivity. The third one is the high sensitivity. The last one is the suitable for complex soil matrix.
Let's move to the methodology. For sample collection, 15 sampling points at the industrial site. For sample have 2 depths per point, like surface soil and subsurface soil. The samples are stored in amber glasses bottles and labeled, and then transported on ice before storage at -20 degrees Celsius. For sample preparation, we have 6 steps. For weighing and speccing, solvent extraction, cleanup, concentration, internal standard addition, and filtration and storage. For instrumental analysis, we choose the suitable GC system, and the oven was programmed from 50 temperature to 310 temperature at 6 temperature per minute and hold 20 minutes. The mass spectrometry was performed in EI mode with SIM ions, and this temperature was mass settings, and this data is mass trace ratios. And for sample injection, load 1 milliliter of extract into the autosampler tray and inject 1 microliter per round under specular mode and ensure solvent and ice peaks. For data processing, we should identify faults based on this, and this is a quality assurance.
Let's move into the results and this discussion. First, let's look at the overall pH levels. All the cell sample contain the 4 to get pH. We show that there are chemical has been built up for a long time. Surface sigma pH shows there is very high. The mean pH we found were anthracite, fluorine, perlin, and BAP, and most of them were 4 to 5 ring pH. Now, let's talk about the spatial distribution. The sulfur had more pH than the deeper levels. This spatial matches the area's long history of field birth. The last is the risks. The high levels of cancer causing 5 to 6 ring pH, like BAP, are varying. But we found 7 topics of battering can be break down the pH, which means the soil may be suitable for the burial, the action, or the natural cleanup. Our GCMS text worked well, even though the soil was complicated. The conclusion, to conclude, the GCMS successfully measured the pH in the soil. This level near the chemical plants were much higher than the narrow industry background levels. There are also have some limited in our testing, but by improving the temperature programming and using internal standards, we can get more accuracy results. Overall, this finding shows that the area needs risk checks, long-term monitoring, and cleanup actions. It's the reference we use. Okay, thank you for your listening.